Welcome back, guys. So we have to learn about something called z-values. What z-values do is they kind of equalize all normal distributions that there are. They let us compare two different normal distributions and say something meaningful about the similarities or differences. They also let us understand the area underneath any normal distribution we may be working with without having to calculate that ourselves, because we'll be able to compare our distribution to the standard normal distribution, for which there exist lots of tables that people have published of areas under different parts. Okay, so what the heck is a z-value? There's a simple formula for it here. The z-value for a particular x value is just that x minus the mean divided by standard deviation. And what a z-value really is how many sigmas from the mean a particular x value is. Let me show you what I'm talking about. Let's say Sarah takes the SAT and gets a 660, and the mean is 500 and the standard deviation is 100. This is example 3, sorry. And Megan takes the ACT and gets a 29. The mean is 18 and the standard deviation is 6. Who should be, more impressed? Who should we be more impressed by? Well, how many standard deviations above the mean did Sarah do? Well, 660 minus 500, she's 160 points above the mean. But if 100 is a standard deviation, then we divide by 100 and see that she's 1.6 standard deviations above the mean. Sarah has a z-value of 1.6. Similarly, we calculate Megan to have a z-value of 1.8. So even though Megan's score seems tiny, because it compares so well to the mean given the standard deviation of that test, she actually did better, so to speak. She has a z-score of 1.8. She is 1.8 standard deviations higher than the mean. Okay, here's a table of z-values from 0 to 1 in increments of 0.1, and the area underneath the standard normal distribution. It turns out that if you want to find the area under your normal distribution, whatever one you're working with, between a range of x values, you can do that by finding the z-values that those x values correspond to, and then find the area on the standard normal distribution for those z-values. Okay, this is going to sound mysterious until we illustrate it with an example or two, but we're going to refer back to this table when we need to find out the areas. In example 4, we have data that have a normal distribution with mean 25, standard deviation 5. We're supposed to find the probability of obtaining a result between 23 and 28. Okay, well, we don't have a table for that, so we have to convert 23 to 28, that range of x values, into a range of z values. Really what we want to do is find the z value of each end. So the z for 23, it's easy, we just subtract the mean, divide by sigma, negative 0.4, and for 28 that should say, we find 0.6. So what we want to do is divide this into two parts. The part between negative 0.4 and 0, and the part between 0 and 0.6. Let me show you what that looks like on the graph. Our x value of 23 corresponded to a z value of negative 0.4. So finding the area between that and 0 corresponds to this green area here. And we can look it up in that table and see that the area is 0.16. Now the table doesn't say any negative z values, but because these distributions are symmetric, we can just use the value for positive 0.4, which is 0.16. On the other side, our x value of 28 corresponded to a z value of 0.6. Using the table, we see that the area of the light blue region here is 0.23. Putting it all back together, 0.16 plus 0.23 gives us 0.39. So, 39% chance of getting a result between 23 and 28. Yeah, I know, there's a lot of steps and it's kind of confusing. We better practice this again. But the main idea was find the z-value of each end of your range and then use the table and a graphical understanding of the distribution to tally up and compute the probability. In example 5, we're told that the average response time for an emergency EMT team to an accident site is 6 minutes, with a standard deviation of 1.2 minutes. And they ask us different questions. First of all, what's the probability of a team arriving between 6 and 7 minutes? Well, just like before, we want to find z-values for both ends of that range. For 6, well, the z-value turns out to be 0 because 6 is the mean. And for 7, we get roughly 0.8. Okay, so we can think about it like this diagram here. And what we're looking for is the area between z equals 0 and z equals 0.8. Well, all we have to do is go back and look at our table and see that that's 0.29. So it must be that there's a roughly 29% chance of them arriving between 6 and 7 minutes. All right. Well, in part B, they want to know what the chances are that they'll arrive in less than 5 minutes. We don't know the z-value for 5 yet, so we have to find that. It's negative 0.8. If we think about it graphically like this, 5 minutes corresponds to a z-value of negative 0.8, 6 minutes to z-value of 0, and anything less than 5 minutes is this blue area here. Well, from the table, we know that the red zone has to be 0.29, and the entire left half of the distribution is 50%, so what's left in blue in that wing there must be 21% to account for the remaining probability. Part C, we're asked to find the probability that they come in less than 7 minutes. Again, we know how this goes. The wings are 21, the middle two parts are 29 each, and so really what we're looking for is everything but the upper wing. The upper wing represents the probability that they would arrive in longer than 7 minutes. So 100 minus that wing is 79, and we have 79% chance of them arriving in less than 7 minutes, which is good news if you're having a heart attack. All right, homework for this section, lighter than last time, I promise. Page 896, 1 through 4 all. Those are easy, but I want you to get practice on the basic stuff. That's why I gave you some even ones. And 5 to 29 odd. Okay, you're going to be referring to that table a lot, I think. So that's the table on page, what is it? Page 895. So become good friends with that table. All right, guys, good luck, and I'll talk to you next week.